Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, Exxon Mobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, Exxon Mobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, a Harbor Energy Company, Bronze Sponsor, Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo.
Hello, good day everyone. Welcome to the 45th IPA Convention Exhibition, Technical Session 2021. My name is Sangmade Kresnandika from Tetli NV. I am your session chair for this session with my partner.
I'm Ibak, Ida Bagus Ari Kresnawan. I'm from Kalian Energy, Indonesia.
Okay, thank you, Pak Ibak. Before we start, I want to remind this room is for session 5. Please make sure you are in the correct room. In this session, we will have 4 papers covering drilling topics. As you can see on the slide, the first presenter will be Pak Sulistyo Rahutomo from Premier Oil. And the second one from Pertamina Hulu Mahakam will be presented by Pak Rahmat Sinaga. And then the third paper will be Pak Irfan Hanif from Pertamina Hulu Mahakam as well. And the last one is Pak Roni Seregar, drilling practitioner. Okay, next. Before we continue to the presentation, I would like to remind all of you about the copyrights and the participant rules, that no part of this content may be reproduced, stored in a retrieval system, or transcribed in any form or by any means, electronic or mechanical, including photocopying and recording, without the prior written permission of the IPA. Next. So, as a participant, you are all expected to be active and participate by asking questions or put comments via the Q&A room or chat box down below at any time during the presentation. Also, please address clear and related question only. Again, we remind you to respect copyright by do not take any recording or screen capture from any kind of devices. So let's start the first presentation. I will hand over to Pak Ibak to host the first one. Pak Ibak, go ahead.
Yeah, okay. Thank you, Pasan. Okay, the first presentation title is Shallow Water Subsea Well Drilling and Completion Utilizing Jack-up Rig at Natuna Sea Block. Next. The author will be Bapak Sulistyo Rahutomo, is a completion engineer from Premier Oil. His bachelor degree 2006 from Petroleum Engineer ITB, and then his previous publication is a jack-up utilization and challenge of plug and abandonment effectiveness of a subsea well at Natuna Sea Block, the 4th second annual IPA convention and exhibition in 2008. And then also the co-author is Bapak Said Faisal, is a staff senior keteknikan pengeboran pengembangan from SK Migas. Bapak Dian Sutejo from Well Development Engineering Manager from Premier Oil, and then third is Bapak Erwindo Tanjung, is a senior drilling manager at the Premier Oil also. So can start the presentation.
Hello, good day, ladies and gentlemen. Allow me to introduce myself. My name is Sulistyo Rahutomo from Premier Oil, and I am delighted to be here today to present the paper that I write together with my colleague Pak Faisal from SKK Migas, Pak Dian, and Pak Erwindo from Premier Oil. The paper title is Shallow Water Subsea Well Drilling and Completion Utilizing Jack-up Rig at Natuna Sea Block. The content of my presentation is as follows. I will give brief introduction about the project, then I will explain about the well construction plan to achieve subsurface objectives. Then I will explain why we select jack-up rig type to execute the project campaign. After that, I continue with required rig modification to perform subsea operation. Also, I will give brief explanation on subsea wellhead and 3 SIT or system integrity test. Continue with explanation on subsea well construction operation. Then I will share about the operational challenges faced during operation. Then I will discuss about the results of the campaign before we conclude with the conclusions. In 2019, 4 development wells are planned to be drilled and completed as per commitment to the field POD. 3 wells are subsea development well, while the other 1 well is surface development well drilled from existing platform. The project requirement dictate to drill the 4 wells in one single campaign. The wells are situated in Natuna Sea Block, which lies near the maritime borders between Malaysia, Indonesia, and Vietnam, with water depth ranging from 250 feet until 300 feet. The illustration of the field location can be seen in the presented map figure. The subsurface objectives for S1 and S2 wells are targeting same formation but different hydrocarbon trap, while the subsurface objectives for S3 well is targeting deeper formation, consists of 2 zones, and require intelligent compression to enable remote production selectivity over 2 produce zones. To achieve subsurface objectives, the wells construction plan are developed as follows. For S1 and S2 wells, the wells will be drilled in 3 holes and casing section. The target sand will be completed using frac pack technology, complete with 4.5 completion jewelries. While the S3 well is targeting deeper formation, the wells will be drilled in 4 holes and casing section. The target sand will be completed using 4.5 intelligent completion jewelries. The well construction illustration can be seen in the figure as presented. As explained in introduction, the project is required to be executed in one single drilling campaign. so that the only rig option is jack-up rig type. Based on tender results, the selected jack-up rig is having Keppel-FELS Super B class design. Then, after identifying the drilling rig contractor, the collaboration work is started in between drilling rig contractor, subsea wellhead, and 3 service provider and Premier Oil to identify the required rig modification to enable required subsea operation. There are 5 identified main key major subsea operations which require rig modifications. First, the subsea tree prior to installation require preparation and inspection by the service hand, so that temporary storage on the rig is required. To answer this requirement, the CTU rig will be enlarged to accommodate temporary storage of subsea tree. Second, the high pressure riser nipple up on top of either high pressure housing or subsea tree require to be tensioned as per riser tension analysis, so that a means to provide tension system is required. To answer this requirement, the rig fabricates suspended Texas deck, or we can call it as STD, and hang under the rig floor to support high pressure riser tension. Third, when the subsea equipment deploy subsea, it requires guideline to allow guidance and resulting smooth installation process. To answer this requirement, the winch is required to be replaced with the length suite with water depth. Fourth, when performing subsea operation nowadays, the remotely operated vehicle is a must to support any subsea operations, so that the rig is required to accommodate ROV spread installation on rig deck. To answer this requirement, the existing rig structure for ROV spread requires strengthening and extension. Fifth, as the subsea tree type is horizontal subsea tree, so that additional well control device, which is subsea landing string valves above subsea tree, is required and need to be spaced out across BOP to allow BOP blind shear utilization in emergency situation. To answer this requirement, existing rig BOP RAM require reconfiguration to allow the subsea control device spaced out across rig BOP. This slide shows the actual CTU deck modification to allow temporary storage of the subsea tree for inspection purpose before installed to the wellhead. The subsea tree is picked up directly from supply vessel using top drive and lifting bridle arrangement, then transferred to the CTU deck. This operation requires cantilever skidding operation. When subsea tree ready for installation, the tree will be made up to high pressure riser, then picked up using top drive before skid the cantilever and rig floor to position the subsea tree to well center. After that, the subsea tree deploy subsea on high pressure riser until it lands and latches to subsea wellhead. This slide shows the actual suspended Texas deck, or STD, hang under rig floor using certified chain as lifting bridle. The figure shows the high pressure riser and rig BOP stack on top of the subsea wellhead. The high pressure riser is tensioned using push table tensioning system located on the suspended Texas deck. The STD, or suspended Texas deck, can be elevated using air tugger arrangement and temporarily stored just underneath the rig floor. This is important just because it serves two purposes. First, to allow picking up the subsea tree using top drive on high pressure riser for installation to the subsea wellhead. Second, to allow temporary storage so that the rig can be mobilized from one well location to another location. This slide shows the actual ROV spread installed to the rig structure, which already strengthened and extended. The deck extension is required for safe ROV deployment using launch and recovery system to avoid vehicle collision with rig structure, while the deck strengthening is required as per the deck load analysis to enable ROV spread load. We did the System Integrity Test or SIT to Subsea Wellhead and tree system together with mock ROV and Subsea Control Module. The SIT is to ensure subsea structure interface and installation are fit for purpose and avoid any surprise in the field. The SIT is run based on anticipated operation using jack-up rig, and some findings are registered and rectified prior subsea tree and wellhead delivery. Bespoke ROV tooling are also identified and procured accordingly. This slide shows the sequence subsea structure installation cartoon. It starts with the 30-inch conductor housing installation on drill pipe, then continue with protection structure assembly or PSA installation on two 30-inch conductor housing, then continue with 13.58-inch high pressure wellhead housing installation run on drill pipe. Then lastly, the subsea tree is installed on two high-pressure wellhead housing inside PSA. During actual operation, we identify several operation challenges as follows. First, there is always first time for everything. This is also applied to us when we carry out subsea well drilling and completion using modified jack-up rig. All crew members are not fully familiarized with subsea well structure installation using modified jack-up rig, so that in this case, learning curve is a key to enable operation timing improvement. Second, the PSA is the biggest subsea structure in our case, so that the only way to install it subsea is by pick up from supply vessel using top drive and lifting bridle, then directly deploy it subsea as shown in the picture. Third, to optimize the rig timing, when the rig floor handling the subsea tree, the rig BOP is put aside and secured by hanging on BOP hoist. This operation requires rigorous operation step sequence to make sure everything goes as per plan. Fourth, the subsea drilling and completion operation using jack-up rig require multiple numbers of rig floor and cantilever deck skidding operation. Before skidding commence, toolbox talk will commence, then every parties need to ensure to secure their equipment such as subsea umbilical, ROV, and subsea guideline, etc. The subsea drilling and completion operation for 3 wells is successfully executed in 129 days, started with S1 well and finished in S3 well. The operations were consumed 319,560 man-hours with 0 LTI and 0 hydrocarbon spills to the environment. The operation time performance can be seen in the show chart figure. The chart shows operation timing improvement on same operation stages. However, some anomaly is noted on. First, 12 and quarter hole section in S3 well has the deepest TD, so that it takes longer to drill. Second, there is 958 pack of issue in S3 well, so that it gives longer timing. Third, there is issue with intelligent tubing hanger installation in S3 well, so that it gives longer timing. If comparing the two wells performance, S1 and S2 wells, which share similarity on well construction, the recorded time was 52 days to complete S1 well and 35 days to complete S2 well, which equal to 17 days of time improvement. There are several identified factors contribute to time performance improvement. First, all onboard crew members were learning from the repetitive subsea operation process. The more experience they gain, the more efficient they perform the tasks, which represent what so-called learning curve. Second, there was change on the operation methodology on handling the BOP after completed drilling to target depth on S1 well. Instead of parking the BOP stack to its stage stamp as it was originally done in S1 well, on S2 well, the BOP stack was securely suspended by BOP hoist and set aside Willis derrick in operation to install Subsea 3 as can be seen in previous figure. Third, operating the STD was originally performed by BOP hoist. Then, in next well, it was changed to be operated by air tugger with the pulley arrangement to properly handle the STD load, which was faster and easier. I have now come to the end of my presentation. The conclusion is the subsea well development drilling and completion campaign in shallow water environment can be effectively, efficiently, and safely performed using jackup rig by having a robust subsea operation planning, by identifying required rig modification, and continuous improvement over the drilling operation. Thank you.
All right, thank you for the presentation, Pak Sulistyo. I think we are Kangen also have a similar operation previously. So yeah, I have a question also. Now we are moving to the Q&A session. There's one question from Pak Daniel Sitorus. He's from the Kangen Energy Indonesia. He's asking about you are drilling 3 wells plus 1 in 1 rig spot location, or you need to move the spot can to its location. I believe this question he like asking about you doing like a batch drilling or drill and complete the wells.
Okay, yeah, thank you for the question from Pak Daniel, Pak Ibak.
Yeah.
Yes, the 3 wells drilled from the different surface coordinate, Pak Daniel, and for sure 1 well is drilled from the existing platform, so for sure it's different surface coordinate than the other rest of subsea wells. Maybe that's answering the question, Pak.
Okay. Pak Sulistyo, thank you for the question. We move to the next question from Pak Rizky Muhammad. Did you perform soil check on the seabed prior to the jackup arrival?
Yes, we did, for sure.
Okay.
Yeah, we did the soil check, yeah, to make sure that, you know, for the leg penetration.
For the jackup leg, okay.
Yeah.
Yeah, okay. Okay, for the next question from Pak Sani. How much the rig modification cost comparing the total cost with other rig for subsea? How much cost comparison?
Well, actually, you know, as mentioned in the beginning, that, you know, we are selecting a jackup rig is because we performing the drilling campaign in for 4 wells in single drilling campaign. So the jackup rig, we are selecting the jackup rig. So we are actually not comparing with the, you know, other type of subsea rig type, just because it's already ruled out, you know, so that yeah, basically we did not do the comparison, cost comparison. So but then for the rig modification cost, I cannot remember on top of my head, but actually it's less than 1 million.
Less than 1 million. I believe you cannot use semi because of the water depth, right? So you need like some draft to get the rig to the location, right? But you still can use that semi anyway.
Oh well, if talking using semi, yes, we can do, but there is some disadvantage, right? Just because considering this is low water depth, right? I mean, we are talking shallow water, right? So we are talking about the more narrow station circle, right? In anticipating in emergency situation, in the case emergency situation to emergency release from the wellhead. And also we are talking about that's the first thing, and the second thing is about the load on the subsea wellhead and tree, right? This is application on the subsea wellhead. We need to be careful with the load on the BOP put on the wellhead and tree, right? So we don't want to put excessive load to the subsea tree and wellhead, which may resulting the wellhead and tree failure in terms of the capacity load.
Okay. We still have time, so there's another question from Pak Daniel from Kayan. If you had others opportunity to drill subsea, are you going to drill with drill ship or semi?
Yes, I mean, yeah.
Yeah, of course.
Yes, for sure. Of course, we are still opening all other alternative, but we need to sure that we need to perform engineering calculation again and make sure that the selected rig type and also all the system is fit for purpose. As I said that there's two points major concerning about this semi-sub performing this subsea well drilling and completion, Pak Ibak.
Okay, thank you, Pak. There's another question from Pak Rian Junaldi. Thank you for the good presentation. Is there any modification on the deck also for iWalks operation?
Yes, thank you. A question from Pak Rian. Yeah. Okay, for the iWalks, no. Actually, we did not do any modification to allow this iWalks operation, just because we the rig itself allowing us to install this to set this iWalks set just underneath the cantilever deck, just near to the transom of the rig, but still under cantilever deck. There is a hatch in between the rig floor and cantilever deck, so then we can install and not basically transfer the iWalks passing through that hatch in between rig floor and also cantilever deck, Pak Ibak. Well, actually, it's hard to explain, by words. But if I providing the pictures, maybe it will be more clearer to explain.
Okay. Actually, I have a question about how you train the jack-up crew with the subsea jobs, but I think we ran out of time, so I think we should wrap up this presentation. Maybe for any question that have not been answered, including me, I will share the presenter or author contact in the chat room, and you can continue discuss offline directly with the author. Once again, thank you to Pak Sulistyo for the presentation. Now we are continue with the next presentation will be chaired by Pak Sang. Thank you, Pak.
Yeah, thank you. I think we still have some more minutes, but it's fine. Ibak.
Yeah.
Okay, so we move to the second presentation for today. The second presentation title will be the first successful rigless monotrip gas lift completion in Mahakam field. This will be presented by Pak Rahmat Sinaga from Pertamina Hulu Mahakam. Pak Rahmat Sinaga is a senior drilling engineer. Got his degree from Institute Teknologi Bandung and Aberdeen Business School, United Kingdom. He had previous publication on the analysis of oscillating fishing tool efficiency for stock assembly recovery in the Field X published in the AATME 2020. Okay, next. The co-authors for this paper are Pak Christopher's Widias Toko. He's the senior completion engineer, PHM. Also, there's Pak Tommy Sugiarto, lead engineer, PHM. Pak Wiryawan Suraji, drilling engineer, PHM. And Pak Miyazi I. Maharoni. He is SW superintendent, PHM. So, okay, let's watch and hear the presentation.
Ladies and gentlemen, welcome to the Indonesian Petroleum Association 45th Annual Convention and Exhibition. As the introduction has been made to our team from Pertamina Hulu Mahakam, I'm Rahmat Sinaga, you can call me Gabe. We'll take you on our journey of the first successful rigless monotrip gas lift completion in Mahakam field with IPA ID IPA 21-E-93. Allow me to read a very short poem in Bahasa, also known as pantun, that will take us to the next slide. Lautan luas Laut Natuna, diapit pulau-pulau bukanlah satu. Selamat bergabung di IPA Exhibition 2021, meski virtual namun tetap berwarna. Have you ever thought of doing a monotrip gas lift completion in your wells? Are you seeking another way of operating more efficiently in monotrip gas lift completion? Or have you considered using a hydraulic workover unit to execute the job as an alternative to a drilling rig? Our paper and presentation could be valuable and helpful to add your reference on how the rigless monotrip gas lift completion project has been done successfully. This presentation is divided into 7 sections, with 6 sections remaining. During this presentation, I'll use the term MTGL alternatively to monotrip gas lift and HW unit to hydraulic workover unit. Time being is allocated to look into the MTGL concept as a completion type in section 2. Then we're going to look at HW unit and compare it with a drilling rig in section 3. While section 4 will introduce the profile of offshore one well, whereby we had performed the first rigless MTGL. Section 5 will introduce the concerns we had, including the strategies we agreed on as a whole team. Then Section 6 presents the results we obtained on this project. Finally, we expose our conclusions and some recommendations based on our project execution in Section 7. We hope you all enjoy the presentation. This section will cover the equipment required and the job sequence as well. MTGL is a completion technique to enrich the conventional monobore and dual monobore architectures to achieve time efficiency and enhance production in depleted oil zones. The MTGL is believed will improve the life of reservoirs and contributing to reducing completion costs. This MTGL technology has attracted our attention due to its success record in around 200 wells since it has been patented by Baker Hughes in 2004. Particularly in the Mahakam field, such MTGL jobs were executed by the drilling rigs. Our data shows that 27 wells have been completed by MTGL since 2017. However, PHM internal study elaborates that using drilling rigs is not favorable financially any longer. Hence, in September 2020, PHM appointed the hydraulic workover unit to perform the job as an alternative to the existing practices. The ultimate objectives of this strategy are to improve efficiency, achieve production goals, and maintain safe operations for people, the environment, assets, reputation, and liability. Furthermore, we take a quick glimpse at the essential equipment of the MTGL job, taking direction from the left to the right, of which that equipment is in order from top to bottom. Inside the well. We can see tubing retrievable safety valves or TRSV 2.81 inch with 10 kpsi handling pressure capability, gas lift mandrel GLM with cement through profile 3.5 inch also with 10 kpsi, hydraulic closed circulating valve or HCCV, which is closed during cementing and it needs to be opened after to clean out the annulus, production packer, pump down plug or PDP with two sets of vanes as shown by the red circles. The purpose is to wipe excess cement out of tubing walls and it will be landing on a landing collar which the inside profile is designed specially for the PDP. Regarding the operational sequence of MTGL completions, BHM has detailed procedures in the completion program of offshore one well as below summary. Cement bond logging or CBL to evaluate cement condition behind 7-inch casing, running in hole, completion string and pieces of jewelry, land and lock the tubing hanger. Perform MTGL cementing job sequentially, pressure up the tubing, set and test the packer. Burst rupture disc of HCCV and clean out excess cement in the annulus. Close the circulating valve sleeves and perform an annular integrity test. Perform TRSV inflow test and once TRSV is confirmed, test it, bleed off all tubing pressure to 0 psi and continue to rig down surface equipment. Getting into section 3 will explain a HW unit in a nutshell and some elements to compare it with a drilling rig. Hydraulic walkover unit is a hydraulically powered jack capable of pulling and running jointed pipe of a well. It comprises guy wires, a blowout preventer BOP system, staircases, window basket, jack basket, working basket, and chain pole. In Mahakam operations, we use HW unit to perform some works that used to be done by a drilling rig, i.e. plug and abandonment and the gravel pack completions apart from the interventions job. This slide illustrates a couple of items that we take to compare a hydraulic walkover unit with a drilling rig. Related to site preparation, HW unit is more beneficial since our record shows that it will take an average of 121 hours or 5.04 days to move, anchoring, rig up, rig down and de-anchoring the unit. Meanwhile, a drilling rig will need average 10 days to do the preparations. Regarding tripping speed, it is noted that a drilling rig is faster due to its mechanical and construction design. Our record shows HW unit gets 75 meter per hour while drilling rig can go 93 meter an hour to run upper completion string. This is the most significant element in comparing the performance of both units. Moreover, both the hydraulic walkover unit and the drilling rig have a non-compromise BOP system that complies with our rules and the international standard. Finally, a hydraulic walkover unit is more favorable to enable simultaneous operation with the well intervention system since the unit most likely works in a non-live well. We're explaining the case study of offshore one well as our first rigless MTGL project throughout these sections. MTGL completion schematic, as you can see on the right side, describes the profile of offshore one well. The well was a re-entry well drilled in August 2020 by a jackup rig. The tie-in point was at 985 meter measure depth, with total depth 2,774 meter measure depth or 2,354 meter true vertical depth. The well has a maximum 62-degree inclination with 32 degree as the final inclination. 7-inch 32 ppf casing was set at 2,771 meter measure depth, cemented the casing without any losses as per the cementing report. In addition to the information of completion equipment in the previous slide, this well will equip 3.5-inch 9.2 ppf tubing to be set at 2,731 meter measure depth, and a float collar which was set right above the float shoe in 2,730.5 meter measure depth. Two pop joints of 3.5-inch as the markers, and a 7-inch permanent packer to be installed in 1,470 meter measure depth, and this depth was designed as the top of cement behind the tubing. Stepping into Section 6, we'll set out the concerns and the strategies we composed and agreed on as a whole team. The first time you do a thing is exciting. That quote has exactly depicted our journey on this project. Also, PHM intended to do it right first time. Taking challenges as opportunities, we began our journey by establishing excellent communication and enforcing success to all stakeholders. We identified three main concerns in the preparation phase. They were cementing engineering, chemicals and equipment, other equipment and contract management, flow rate for packer, and top of sediment or TOS issue. Each concern is explained on the next slides. Firstly, we'll talk about cementing engineering, chemicals, and equipment. MTGL cementing will need slurry composition to meet PHM standards. Besides, it will require simulation and calculation to determine a couple of things such as centralizer standoff profile and the surface pressure when the plug bumps. Unfortunately, the requirement is not covered within the existing contract of HW unit. Besides, the contractor hasn't had any experience in conducting such MTGL cementing job, thus limiting their knowledge to PHM cementing standards in slurry properties requirement and the how-to procedures. Therefore, PHM engaged another cementing company to help the contractor in preparing the job. Series of meetings and discussions have been conducted to ensure that the contractor can provide the requirement in due time. Another thing is to ensure that the pumps are fit for MTGL cementing purposes. PHM and the contractor agreed to perform some tests for the cementing pumps. Incorporating the simulation result in the testing plan, PHM set the details as described on the next slide. Second point is other equipment and contract management. In HW unit, there are many services are managed through a call-out contract. Therefore, PHM arranged a negotiation meeting and jot down list of equipment required that fit for the MTGL job only with some discount schemes. Another example, a drilling rig has also a monthly package contract with electric line provider to perform CBL, whereas HW unit has only a call-out contract. Consequently, it will be more expensive to conduct CBL by electric line in HW unit rather than in a drilling rig. To manage the challenge on the contract side, we then conducted CBL in memory mode on slick line, and we have obtained a reliable result of CBL with a more reasonable cost performed in such way. Finally, the flow rate for packer and top of sediment or TOS issue. PHM has studied internally the height of TOS in the MTGL wells completion is around 16 to 21 meter, which has to be cleared out to access the most bottom zones. Remedial work would incur additional costs. Hence, the TOS became a significant challenge to overcome. Based on the historical data, we identified probable causes. They are utilization of 4.5-inch landing joint, whereas the cementing plug size is only 3.5-inch. Less efficiency of the cementing plugs veins and insufficient flow rate when displacing the cement. On the other hand, we were also suggested to limit flow rate to maximum 3 barrels per minute to prevent washout on the packer element by the packer provider. However, such flow rate would not provide enough turbulence to prevent cement contamination. We finally decided to apply a flow rate as simulated and are ready to install another packer as a remedial job if the permanent packer fails to set. Although we plan to modify the plug vanes to address the cause of high TOS, we haven't been able to finalize the plan as there was no engineering feedback from the company provider in due time. Hence, we kept using the same design of MTGL cementing plug as it is normally used. Chart A on the left side shows the PHM requires more than 80% standoff at the centralizer, while the red line shows the result of 33%, means that the amount and placement of our centralizers on the tubing joint has complied with our company rule. Chart B on the right side describes surface pressure expected when the plug bumps, that is 1088 psi on the surface. This means that the value is still able to be handled by the surface lines on the HW unit, which is maximum 5000 psi. As promised, we present this table to show each kind of test that the constructor has to do, including the minimum time required for each test as we obtain from the cementing simulation. As a bottom line, the MTGL cementing itself will require 94 minutes to complete the job. Hence, the contractor's pump have to endure that value. The test is also intended to ensure all surface sensors are in good shape to support this job. Finally, the horsepower test has to achieve 190 horsepower as required. Section number 6 is going to explain the results we achieved on this project. This slide presents two figures A on the left and B on the right side. Figure A summarizes time and its sequence of the entire MTGL completion by HW unit. Although unloading well is included in the chart, time required to unload the well is not counted as a performance indicator of this project. We present the activity in this chart just to give a reference for the future job in case of the unloading well is required. Next, figure B describes the entire time to perform the first reckless MTGL. We have achieved 92% productive time and 8% of the total time to wait on weather. The job has been completed within 11.6 days safely and successfully, and no lost time incident accident nor the non-productive time or NPT throughout the job. Regarding TOS, the 1.9-inch macaroni assembly has tagged TOS 13 meter. Although the TOS is not as low as expected, the result has shown improvement in TOS height compared to previous MTGL wells. Another thing we'd like to share regarding the cementing pump conditions. We had problems with transfer pumps when transferring cementing chemicals before mixing the slurry. Therefore, it is strongly encouraged to capture this lesson for the future, including the way to do a quick fix. Furthermore, this figure illustrates the time and cost comparison of performing MTGL completions by a drilling rig and HW unit. Although HW unit needs more days to perform the MTGL completions compared to drilling rig, HW unit has spent less money for the particular work. Time consumed to run tubulars or completion equipment and to perform cementing itself have played dominantly in the performance measurement. In terms of costs, hydraulic workover unit is considered more efficient to perform NTGL completions rather than a drilling rig. Although some services and equipment to support this rigless job are call-out basis, the strategy to manage the challenge has successfully optimized the expenses. The effort has been paid off by saving 12% compared to similar job by a drilling rig. That brings us to the last section of the agenda. I'd like to summarize by a couple of conclusions and recommendations based on our case study as follows. Hydraulic workover unit has proven as an alternative method to perform the monotrip gas lift completion efficiently and safely in offshore one well. It has contributed to saving compared to a drilling rig for a similar job to meet the objective of executing the rigless monotrip gas lift. Although time spent by HW unit is more than a drilling rig, the rigless MTGL performance still can be improved through a continuous learning curves. Besides maintaining the methods we have applied, we strongly recommend modifying the vanes of the wiper plug with careful examination and engineering study by the equipment provider. as such provides more efficient wiping of excess cement in MTGL wells for future jobs. And after all, it is worth examining the services and equipment contracts and fine-tune the most efficient initiatives to reduce expenses, thus increasing saving. This slide ends our presentation, and we'll be happy to discuss further in the following session. We are honored to have been selected in this 45th Indonesian Petroleum Association Convention and Exhibition 2021, and we hope our sharing on the first rigorous monotrip gas lift in Mahakam field is fruitful. Last but not least, allow me to read a very short poem which is dedicated to all of us who work in the oil industry. The works in the oil field can't be done alone. They require teamwork, free or foursome. Working safely is our clone. Keep up focus, stay safe and handsome. Ladies and gentlemen, appreciate for all your attention.
Okay, what a great presentation from Pak Rahmat Sinaga. I have heard a lot about the success story of these projects. So we move to Q&A. So we have Pak Rahmat Sinaga here with us. We already have several questions. So the first question for Pak Rahmat is from Pak Bayu Buana Natanagara. So he said, thank you for the excellent slide. Related to the cementing, what are the critical endurance tests performed in the cement slurry design related to the MTGL well? Maybe Pak Rahmat or you can answer that.
Okay. Yeah. All right. Thank you, Pak Salmade. Thank you, Pak Bayu. Yeah. Basically, we did a lot of work to prepare the contractor for this job. So baseline is to meet the PHM standard in cementing slurry design. As far as I could remember, we spent a lot of time in preparing properties for the anti-migration, the fluid loss control, and also one thing that critical in PHM is like the former as well to meet the criterion set by the PHM. That's for the cementing slurry test. If you're talking about the endurance, that we also did another test for the cementing equipment itself. So like the previous slide in the table, you can see there are three main items that we did to test the sensors, the pumps, and the horsepower of the pump itself.
Okay, I think the question is related to the cement slurry.
Yeah,
I think it was answered. Okay, we go to the next question. It's from Jerry Tobing. He said, "Congrats for the success story, Pak Gabe. Is there any cost comparison with the earlier production opportunity by using the rig compared with the hydraulic workover unit?"
Well, we haven't done the study for the cost comparison to compare the execution between the drilling rig and this HW unit regarding to the production result. You mean that what I understand from this question is the production result. Is that correct?
Yeah, is it cost comparison with the earlier production opportunity? So I believe if you haven't done that, so I think maybe it can be planned for a future paper, Pak Rahmat.
Yeah.
All right, so we move to the next question. Pak Jerry, if you still have more questions, you can again put a question on the Q&A box. Okay, we move to the third question. Pak Rian Aditya from PHE. So excellent presentation again, Bang Gabe. A lot of your fans here. But since the system is run or activate in the case hole, can we remove the THT packer? That's first question. Second one, what is the main concern to keep installing packer? Okay, so I think we go for that two questions first because yeah, there's a few following question after.
Okay, so can we remove the THT packer? Yeah, because the THT packer is a permanent, so the only way we cannot remove it at all. The main concern to keep installing the packer, because we have a lot, like the GLM, and we want to isolate the annular with the section of the GLM where the GLM are set.
Okay, so I think that's go to the following question. So another thing he asked, can we use conventional GLM since it's a CH environment, higher circulating rate is expected, then it will help create more turbulent flows across the GLM to clean the sectional area from the possible cement debris. All right.
Yeah, I believe we can use the conventional GLM, yeah, but at the time we didn't take another study for this, but we use the circulating rate. The design of the circulating rate that we design on this project is maximum 10, and we hope that the XW unit can achieve that rate. So if we use the conventional GLM and we'll need higher circulating rate, then I don't think we can proceed with that option.
Okay.
Yeah.
All right. So because Pak Rian already asked, I have a question also related to the permanent packer. So any contingency plan if the permanent packer is failed to be set properly? Do you have to pull out or? Yeah, of course. We for this type of packer, the THT, it will be stay in the well forever because it is the permanent one. The only way we can do something like a remedial is we need to cut the tubing above the THT packer setting that, and we remove and install another one. That will incur a lot of time and a lot of cost for the remedial job. Yeah, because that's your well barrier, right? So yes. Yeah. Okay, so it's very critical to have that. I mean, on that particular event to set the packer. All right. So next question from Fadli Satrio Fajri from PSR. So hydraulic walkover unit MTGL completion is proven much cheaper than rig completion, but it was also need more rig days, which mean increased loss opportunity to put well on production ASAP. So I mean, you have you know, lower cost but higher operating days, then you lose your days to get your production earlier. So that maybe also question from Pak Jerry. Yeah, I believe so. This is related to the Pak Jerry question. Yep. Aforementioned. So now I understand the question. All right. So we haven't done any study to compare this, but it will be always a trade-off. Yeah, I mean,
In one case, we could lose the opportunity for the production, but another hand, you know that the faster the rig move from that platform, it means the more opportunity for the rig to produce another wells to be produced later. So it will be like a kind of a trade-off to be mitigated. Yeah. So the planning, the thorough planning, the comprehensive planning will be critical on this element. Yeah.
Okay. All right. So we still have 1 more minute, but I think it's not enough to answer the rest of the question. It's a lot of interest to your paper, Pak Rahmat. I think to all the participants that already have questions, already submit questions that haven't been answered, I will put the presenter email address on the chat box, so you can correspondence or discuss directly to the presenter throughout the email correspondence. Thank you once again, Pak Rahmat. Great presentation. I hope for the next success. So we go to third presentation. Will host by Pak Ibak. Please, Pak Ibak.
Yeah, thank you, Pasang. We go to the third presentation. Title is One Phase Well of PW, Unlock Shallow Reservoir Efficient and Economically by Eliminating Surface Casing. The author is Bapak Irfan Hanif. Is a drilling engineer at the PT Pertamina Hulu Mahakam. His background bachelor degree in chemical engineering at Institute Technology 10 November, and also have a diploma degree in chemical engineering Institute Technology 10 November. And the co-author is Ramarandito Sayuglo, drilling engineer, who's from PSM. Pak Tiko is a drilling engineer. Bapak Praja Distira is a drilling engineer, and also Ibu Karina Sari is a senior engineer. So with no further ado, let's watch and hear the presentation.
Hello, ladies and gentlemen. So today I would like to present our topic in the 45th IPA Convention and Exhibition, Realizing Indonesia's Energy Vision Post-Pandemic. So our topic is we will talk about one phase well, OPW, unlock shallow reservoir as efficient and economically by eliminating the surface casing. So the author is me, Irfan Hanif, Brahmaranito Sayogyo, Rico, Praja Disira, and Karina Sari. And we are all from PT Pertamina Hulu Mahakam. Okay, here's our outline. So in this presentation, I will divide it into 3 parts. First, I will talk about the background and objective, and the second about history and the methods, and the final, I will talk about the result and the conclusions. So let's beginning in the first section about the background and the objective. So I will tell you in the background about the Mahakam problem in the current situation and our objective to solve our main problem in Mahakam area. Okay, let's talk about the background. As you know, Tunu is a field in the Mahakam area, Kalimantan. And Tunu has been in development for almost 30 years. So it has been put Tunu into a mature field. And we got a natural decline of Tunu gas producer. Also, as you know, Indonesia has got the oil price drop. So here are our first background, and this is the Mahakam challenge. And to be specifics, Tunu Shallow has been developed in Mahakam, which has Tunu Shallow has depth between 50-100 meters until 2,000 meters of the well depth. And Tunu drill in two phases. First, drilling in the surface section, and then continue drilling reservoir section. Okay, as you see from the graphic, you will see the duration of the shallow architecture well is averaged in 6.6 days per well. It's from period of 2020. And our cost of SLA is averaged in 51 million rupiah, or it is equal to 3.65 million USD per wells. It's from period 2020. So our main problem is we need to reduce the duration of the constructing of the Tunu shallow zone, and also to cut the cost for constructing Tunu in shallow area. So let's talk about our objective. First, our objective is to unlock marginal reserve. As I told you before, Tunu is a mature field, which has get the natural decline of producing a gas. So our problem too is our reserve is getting more decline too. So we need some new innovation to unlock the marginal reserve and get the well economically. And the second, we need to reduce the duration for well construction, so we could get cost efficient to get economical well. So these are the three objectives to solve our problem in Tuna area. Okay, let's start the second section. In this section, I will tell you about the history of Tuna area and the methods of our innovation one phase well. Okay, here's our roadmap to one phase well in Tuna area. In the beginning of 26, we start to develop two-phase drilling, which is we drilling the surface section and continue drilling the reservoir section in shallow or in main zone. And this procedure has been proven due to the operational feasibility. In the beginning of 27, we start to develop the Tuna shallow area. And in the 2018, we start to replace our synthetic base mat to water-based mats. This also the proven concept. So in Tuna area, for now, we drilling the Tuna shallow using a water-based mat, both in surface section or in reservoir section. And in 2018, also, we start to drilling using Deepwater in the reservoir section, and it has been successfully in Tunu and N1 and Tunu and N2. We also trial to do the surface casing perforation, and it has been successfully too in Tunu LL5, Tunu LL8, and Tunu TT9. We also start to trial drilling using LWD, but without any radioactive. This purpose is this purpose is to we would like to replace the neutron density in an half inch open hole section, and from our trial we conclude that LWD sourceless is confirmed based on the real-time data. In the beginning of February 2019, we get OPW session with the SK Kamigas, and in the May 2019, We get project socialization with Dirjen Migas, and also we get project review with APH PSI. In 2019, in the beginning and in the end of 2019, we start to got our first trial drilling first one phase well in Tuna and N7, and it has been successfully. So in 2020, what's next? We have been through all this step until reach in 2090 successfully drilled the first one phase well. So we hope we could industrialize the one phase well architecture. Okay, why OPV? So we hope OPV could help us to lowering cost and shorter well duration. Since in one phase well, we will eliminating the surface casing. So we hope by eliminating the surface casing, we could reduce the well duration and lowering our costs. And the second and the third is OPV could increase ECD window, reduce risk of stuck, and less prone from burning phenomenon. Why? Because in one phase well, we drill 9.5 inch open hole using 5-inch drill pipe, or we drill 8.5 inch open hole using 4-inch drill pipe. As I told you, 9.5 inch open hole with 5-inch drill pipe is have more clearance compared to our drilling in reservoir section by using 8.5 inch open hole using 5-inch drill pipe. So let's talk about the differences architecture between one phase well and SL. Okay, you will see the difference between the Tuna shallow light architecture and one phase well. In Tuna shallow architecture, we driven the 20-inch conductor pipe prior rig arrival, and then we continue drilling 12.14-inch surface section 2TD, and then continue run in hole 9.58-inch surface section and cementing to surface up to surface. After it has been finished, we start to drilling 8.5-inch reservoir section 2TD, and then we continue run in hole 3.5-inch tubing. In one phase well, we eliminated the surface section. The same is we driven 20-inch conductor pipe and then continue drilling reservoir section to TD. So the reservoir section will be 9.5-inch open hole or 8.5-inch open hole. And in one phase well, we cement up 3.5-inch tubing up to surface. Both the operation of Tuna shallow light architecture and one phase well utilize a water basement. Okay, here's are the method between the ESLA and OPV. As I told you before, in SLA and OPV, we install conductor pipe prior rig arrival. And in SLA, we start to install the diverter, continue CP clean out using 12.14-inch BHA, and then continue drilling 12.14-inch surface section 2TD, and then pulling out of hole, and continue to run in hole 9.58-inch casing and cementing, nipple down diverter, recap BOP, continue drilling 8.5-inch reservoir section 2TD, and pulling out of the hole, run in hole 3.5-inch tubing and cementing, and then nipple down BOP and install Christmas tree. And in OPV, we only install the diverter. We don't need to nipple down the diverter and recap BOP. After we finish install the diverter in one phase well, we continue CP clean out using 17.5-inch BHA. Why 17.5-inch BHA? We need to get a good standoff between 3.5-inch tubing to 20-inch casing CP. So we hope our CP have a good clean out. And after we finish the clean out CP, we will pulling out of hole and run the gyro to get our CP survey. After it has been finished, we pulling out of hole the gyro. We start to drilling reservoir section to TD by 9.5 inch open hole with 5 inch drill pipe, or 8.5 inch open hole with 4 inch drill pipe. And then we continue to run in hole 3.5 inch tubing and cementing. In this part, we will cement the tubing up to surface, and to have a good standoff, we will utilize the bigger central reserve in 3.5 inch tubing. And then after it has been finished, we continue to nipple down the diverter and install the Christmas tree. So as you see, one phase well is more simplified compared to SLA. And we hope by this simplified, we could reduce the time of rig duration and also reduce our cost. So we could unlock our marginal reserve economically. In the final part, in the final section, let's talk about result and conclusions of one phase well.
From several operation of one phase well, we get a summary of results. First, you could see in one phase well operation, we have no any HSE and HQ incident, which is in terms of safety, one phase well could meet the standard. In terms of well delivery, in 2020, PHM successfully drilled 15 plus one phase well wells with average duration 3.7 days. As I told you before, in the beginning, our SLA average duration is 6.6 days. So one phase well could cut up to half in terms of duration of constructing well. In terms of cost efficiency, one phase well could optimize to 300,000 USD per well. As you know, from the beginning that I told you, our cost in constructing SLA is 3.65 million USD. In terms of integrity, 90% of one phase well drill has no any integrity issue, but only 2 well got SICP. In terms of performance, our average ROP is 46.733 meter per hour, average unbottom ROP 80.43 meter per hour, maximum average ROP 60.51 meter per hour, and our maximum unbottom ROP 123 meter per hour. So we could conclude, in terms of performance, OPW has shown the good performance compared to SLA. So we get a small conclusion of one phase well from the result. We could reduce our well duration, optimize costs, no HSE incident, and one phase well has a good performance. And the last ones, 90% of one phase well has no integrity issue. From the result that I told you before, we could conclude that one phase well in several things. First, one phase well has successfully performed cost optimization. For the value, it's up to 300,000 US dollar. And in terms of duration, one phase well successfully reduced the duration of well constructing from 6.6 days to 3.7 days per well. In the for the long term, we could construct well more compared to SLA in 1 year. Second, one phase well still have big room for improvement, such as we could extend it one phase well architecture like one phase well MTGL, one phase well GP, or one phase well SAS. For now, our team still study on that improvement or initialization. And last, for constructing one phase well, we could possibility replace rig with HWU. So it means we could get additional cost optimization for one phase well.
Stay safe, everybody, and have a good day. Thank you.
Thank you for the presentation, Pak Irfan. Now we are moved to the Q&A session. Yeah, we have a question from the audience. The first is from Pak Kostam Siregar. Thank you for the great presentation to low-cost shallow drilling. However, how do you assess that the area is free of shallow gas, and also the OPW method to skip nipple up UP? There's some comment also from him. As far as I know, run LWD or Sonic is costly compared to LWD with exhaust.
Okay, thank you for your question, Pak Kostam. So, in one phase well, we still have a shale gas anomaly. And in Mahakam, in the last few years, we are depends on our main zone in Tuna area. And for now, since we have depletion, since we have a depletion and oil drop price, so we want to see in shallow reservoir in Tuna area. Our environmental is in swamp area, so most probably if we have any well control issue, we could be neglected because we are in a swamp area. And sorry, okay. And yeah, our reservoir or our geography is a strong water aquifer, so we could ensure no water losses during operation. For LWD Sonic in Mahakam, based on contract, we have a same value between LWD Sonic or neutron density. But for now, one phase well is utilize density neutron too. Thank you. Maybe any other answer from my team.
Hello, my name is Karina. So if I may add into the answer is that we start to moving from drilling main reservoir, which is pretty expensive because of the depth of the well, into a shallower wells, which is Tunu shallow. And drilling this kind of wells, we are actually targeting a shallow gas reserve instead of avoiding the shallow gas itself. And to answer one of the question, we did not skip to nipple up the BOP because it is very shallow and the fracture gradient is very low. We are unable to use a BOP because if we try to shut in the well, then the fracture gradient, the formation will not hold itself and it may collapse or even create an underground blowout. So diverter and also using the mud hydrostatic itself is even better for our case in drilling the shallow reservoir. And the LWD Sonic, so is it true? It is true that it is more expensive, but it is safer in one way. So we are avoiding to bring the neutron tools or radioactive tools, because if worse come to worse and we got stuck, then we will left the radioactive in a very shallow depth. However, with several practice, we identified all of the risks and more confidence in drilling this kind of wells. Now we are able to use a normal LWD density neutron to help identify which gas reservoir that coming from the sand or coal. So now we are starting to run normal LWD. I hope that answer Pak Kostam question.
Okay, thank you, Karina, and thank you, Pak. We go to the next question. I think this one is similar from Pak Fadli Satrio Fajri. and Bayu Buana.
Yeah, I think for the BOP things we can hear from Ibu Karina explanation. Is not they are not skipping the BOP, but it's dictated by the condition. All right.
That's right, Pak. Okay. Go to the next question from Pak Muhammad Dani Aulia Fikri. Is there any technical consideration to choose the OPW operation besides the economic benefit?
Okay. So this is question number 2 from Pak Fadli and Pak Bayu, ya. Okay. So we have several best practice in one phase well operation. The first one is we connector pipe clean out using 11% KCl concentration to prevent from sand sand expanded. And then we have drilling open hole, yeah, with optimized ROP. We limited the ECD drilling is 0.5 to minimum hour factor gradient in CPSU. And at TD, we several times displace the mud from 1.15 to 1.17 to compensate the bottom hole circulating pressure. Mungkin and maybe that's all from the shallow gas best practice. We also in one to stand we pump high fish to ensure our hull cleaning. Maybe that's also from me to ensure one phase well best practice and well control issue. Maybe from other side from my team.
Okay. Pak Sang, maybe you have any comment, Pak?
Oh no, we we can move to the next question, I think.
Okay. Next question is from Pak Farid Hadiaman. That's what was the cause of 2 wells with SICP? Is the well under deviation? Deviation, yeah.
Okay. Okay, Mbak Karina.
So all of the wells that we drill over here is actually a deviated wells. They are between 30 to 65 degree inclination. So, but the sustained casing pressure is not only because of the deviation, but more into one or another thing. So we are truly depending into the cement as the barrier in these wells. And although we plan everything in accordance for good cementing practice, but some of the cases are still happen. So we have been using a gas tight slurry. We've monitored the displacement and we ensure bump plug. However, we still observe sustained casing pressure, but this is not something that we should worry about. So we put several extra mitigation on this one phase well. We have a bleed off line that securely connecting the 3-inch ball valve in the conductor pipe pin connector into the flow line, for example. So we ensure that the sustained casing pressure is not breaching, and we are not opening the valve and causing even more damage to the system. So what we do is just bleed it off safely into the flow line and monitoring the progress and then the development. So all of these one phase well are actually considered as a fast and cheap wells. So we understand that there might be some progression happen, but we will be ready when those times are comes. So we prepare several strict mitigation, for example, by keep monitoring the well. I hope that answered the question.
Yeah, there's an additional question or comment from Farid. Deviation means derogation or deviate from the Pertamina standards in well integrity management.
Oh, okay. So the Pertamina standard is actually a little bit with SNI, which is using a BOP over drilling the reservoir section. However, in our case, the well is very shallow, and because we are drilling in the swamp environment, it means that the overburden is not as high when when we are drilling in the land, right? So we are unable to use a normal BOP mode, because when we're drilling with the normal BOP mode and put two section instead, the kick margin will be dropped, for example, from 8 into 2 meter cubes. So we will not have any capacity to complete the well safely and even put the well into more risk. So we put a special derogation to be able to complete this reservoir section with the diverter.
Thank you, Bu Karina. I think because of the time, I think we should wrap up this presentation. For any question that has not been answered, I will share the presenter or author contact in the chat room, and you can continue discuss offline directly with the author. Once again, thank you to Pak Irfan and the team for the presentation. Now we are continue to the next presentation. The host will be Pak Sam.
Okay, thank you, Pak Ibak. So we move to the last presentation of the day. We have the fourth presentation with the title History of 50 Years Deepwater Drilling Activities in Indonesia from 1968 to 2020. So this presentation will be presented by Pak Roni Siregar. Next. So Pak Roni is a drilling practitioner. He was graduate from ITB, the petroleum engineer, and then he got his master in well engineering from University of Stavanger, Norway. He has a lot of various publication on the IPA, SPE, and IATME, as you can see on the slide. Next. And this is the co-authors of this paper. The first, there's a co-authors from Teknik Perminyakan University Pertamina, Pak Firman Cahya Putra Adistia. The second co-author is Rahmat Hidayat from ITB as well, Petroleum Engineering. And then the third author is Pak William Lim, is from University of Pertamina as well, Petroleum Engineering. Okay, so let's start and watch the presentation.
Good days, ladies and gentlemen. Salam sejahtera for all of us. It is an honor for having opportunity presenting our paper about history of 50 years deepwater drilling activities in Indonesia since 1968 to 2020. Before I start, I would like to give a gratitude to NRK for contributing to NR Club program, where there is forum able to facilitate student or fresh graduate collaborating with practitioners for having research together. Outline of today's presentation is background of the study, methodology, how we were performing the research, and also challenge that we have, result of the study, which consists of details of history and also statistic discussion. Finally, the conclusion that we have from the study. This study is inspired by the curiosity to know the history of deepwater activities in Indonesia. Therefore, it is nice to start look back on the oil and gas activities in Indonesia from the beginning. First oil well drill at Cirebon on 1871, on 1968 first PSC with Deepwater area at offshore Timor. First Deepwater well, Alveolina 1, drilled at South Java Sea on 1972. And the highest production of crude oil of Indonesia reached 1.68 million barrel oil per day on 1997. And currently, Indonesian production is dominated by gas compared to crude oil, with production contribution of deepwater well only 7.7%. But on the other hand, approximately 70% potential of hydrocarbon reserve in Indonesia is predicted located in offshore area. Research of deepwater activities since 1968 to 1992 was done previously, but since then, until current, no publication yet that capture whole activities of deepwater in Indonesia. Indonesia is a meeting point of three large tectonic plates: Eurasian plate, Indian Australian plates, and Pacific plates as shown in figures. Big island of Sumatra, Java, Kalimantan, and smaller island in between are attached to the Sunda Shelf, which is part of the Asian continent. Further to the east, Big Island of Papua and Aru Islands are attached to the Arafuru Shelf and also Sahu Shelf, which are part of the Australian continent. These two ancient continental land masses have relatively shallow water depth, not exceeding 200 meters. The area in between those continents is where deep sea that could reach a water depth of 5,000 meters deep, where normally in this water depth only able to be drilled by using floaters. Again, that area is where the interest of the study. Currently, over 800 sedimentary basins worldwide are identified. 128 basins, or more than 1/7 of it, are located in Indonesia. Wondering which basins are having the water environment and what are the status? Has it been explored? The study was started by screening the deepwater well based on water depth and location. Next stage is gathering the data from the literature, such as publication of conference papers, official government website, etc., and also interviewing some of practitioners. The data was cleaned up, compiled, and validated, which end up of 40 basins with deep water environment and 276 deep water wells were identified. Each well consists with details of well name, well type, year drilled, company name, basin, and so on. From here, the data was being analyzed quantitatively as a basis for writing the history. One of the major obstacles during the study was lacking details some of the wells. It was hard to find complete information, but overall, the completeness data is about 88.6% with some missing information as described here. Out of 128 basins, 40 basins are identified as basins with deep water environment. Those are colored with yellow and red. 33 basins are located at eastern part of Indonesia and rest at western part. Yellow colored is showing 17 drilled basins and red is showing 23 undrilled basins or unexplored on their deep water environment. From the figure, this is showing most of the basin with deep water environment at western part of Indonesia has been explored. Kutai Basin is the only basin with deep water environment that has been produced. North Sumatra Basin, where Jambu Aye Utara Field is located, and Laut Timor Basin, where Abadi Field is located. These two basins are basins with hydrocarbon discovery and approved plan of development by Government of Indonesia, but not yet produced. As previously mentioned, the first PSC acreage, which included a deepwater area, was awarded to International Oil in April 1968. The working acreage was located in onshore and offshore Timor. In 1971, Shell signed a PSC for offshore South Java Basin. 2 wells were drilled there. Finally, on 1992, 3 years after implementation of incentive for deepwater and frontier areas, 24 deepwater exploration wells have been drilled. Deepwater exploration at Western Indonesia. After discovery of Perintis 1 by Mobil Oil on 1994, it proved the existence of a petroleum system at East Kalimantan shelf edge. Later, UNOCAL brought saturation exploration method and a fast drilling in order to minimize cost by utilizing semi-submersible rigs with surface POP. In period of 1994 to 2005, over 125 exploratory, wildcat, and appraisal wells have been drilled by UNOCAL. These efforts provided 10 deepwater fields with commercial discovery. Tarakan Basin was also explored initially by Skeptre Resource with Vanda 1 wells on 1991. The exploration in Tarakan Basin was vacuum until UNOCAL was drilled Bougainville 1 well for Shell on year 2000. Later, ENI was drilled 11 wells in that area since 2004 to 2011. Deepwater Java was massive drilled specifically at Northeast Java Basin before deepwater exploration at Kutai Basin. It was started on 1984 with Amoco until around early 2000 with BP. Latest well drill at this basin was by Kangean Energy on 2016. The South Java Basin was explored by Shell around 1972 to 1973 without further exploration activities since then. Only 2 of 3 basins at Deepwater Sumatra that has been explored. Impact was drilled deepwater wells at North Sumatra Basin for the first time on 1985. Later, ENI drilled 2 wells on 2008 to 2009, and NICO drilled 1 well on 2012. The other basin in Bengkulu Basin. Total was spot a deepwater well on 2014 at that basin. Deepwater exploration at Eastern Indonesia. Deepwater Sulawesi, Lariang, South Makassar, and Spermonde Basin was being explored since 2003 until 2007 by UNOCAL. Afterward, on 2009 until 2013, several oil companies such as ExxonMobil, Statoil, Marathon, ENI, ConocoPhillips, NICO Resources, and Talisman have been explored that area without significant discovery. If you go to the east of the Deepwater Sulawesi, there are 7 basins: Waipoga Sulu, Palung Aru, Saram, Bintuni, Musol, and Salawati, with deepwater environment that have been built since 1973 by Tesoro, 1990 by BP, 95 by UNOCAL, 2001 by Nexen, and 2011 to 2013 by Hess, Mobil Oil, NICO, and Vianosi. On the very south and eastern Indonesia, where Timor Basin is located, Inpex was drilled the first deepwater well on 2000, which discovered Big Field. The exploration activities were continuous until 2014. Talking about deepwater development, so far only 5 deepwater fields are producing currently. They are West Seno, Bangka, Jangkrik, Jangkrik Northeast, and Marrakesh fields, and all of them are located at Kutai Basin. Jambu Air Utara field and Abadi fields are having POD approval on 2012 and 2019 consecutively, but not yet produced. An IDD project was ongoing for selling to new owner. This table is described when was Deepwater field discovered, final POD approved, and on stream. From this table, it shows that West Seno field is the first deepwater field produced in Indonesia on 2003. Bangka field is the first subsea deepwater wells produced in Indonesia on 2016. This table also shows how long it takes to put field on stream since first discovery. It comes up required 5 to 17 years in range. From the gathered data, in summary, the data can be presented shown here. 276 deepwater wells consists of 224 exploration wells and 52 development wells has been drilled. 17 basins with deepwater environment has been identified. Range of measured depth for the wells from 1,400-ish to 6,500 meters have been drilled. Almost 50 years deepwater wells have been drilled in Indonesia so far, with the water depth up to 2,266 meters deep. 30 companies operated across 35 concession blocks. 5 deepwater production well fields have been produced. Finally, 26 drilling rigs at least have been operated to drill deepwater wells in Indonesia. Take a look on the distribution of drilled deepwater wells across Indonesia. At western part, out of 7 basins, 6 are drilled with 85% of all deepwater wells in Indonesia. And most of them at Kutai Basin, which mostly drilled by Unocal. And the rest were drilled at the western part of Indonesia. As previously mentioned, almost 85% deepwater wells were drilled in western area of Indonesia. This figure shows also, even though in the eastern part of Indonesia, many basins with deepwater environment, but not many have been drilled. "30 oil and gas companies have been operating in Indonesia so far up to today. Unocal was drilled the most deepwater wells in Indonesia, followed by ENI, Inpex. This figure is trying to plot number of drill wells every year since 1972 to 2020. Yearly oil price also plots there for reference only. It is concluded that on 2004, it was the most number of drill wells in history of Indonesia. Around 30 wells were drilled at a time. That was also same time when West Seno field was being developed. Pananda 1 well is the well where have a deepest water depth. The well is drilled in basin of Lariang with water depth of 2,266 meters, with measured depth of 6,000 meters. It was drilled by Naiko Resources on 2013. And Lengkuas 1 is the well with the deepest measured depth of 6,500 meters, with water depth of 1,095 meters. The well was drilled by Murphy Oil Corporation back on 2011. Seeing distribution wells that been drilled by 3 type of drilling rigs, it is concluded that semi-submersible rig is mainly used to drill deepwater wells in Indonesia compared with drillship and semi-tender rigs. Finally, the research is providing comprehensive historical of deepwater drilling activities, both exploration and development production in Indonesia for 50 years, since 1968 to 2020. 40 basins with deepwater environment and up to 276 deepwater wells are identified. Recommendation: the accuracy and the completeness of the data can be improved for future study. From this research, there is potential study that could be done in the future by utilizing the gathered data in the study. Thank you for your time and have a good day. Terima kasih.
Okay, so we have seen the last presentation by Pak Roni Siregar. We have Pak Roni and Pak Rahmat here to answer the Q&A. So, right, we have three questions, Pak Roni and Pak Rahmat. The first is from Pak Rahmat Sinaga. Present is the key to the past. So how do you see the future of deepwater drilling in Indonesia from the perspective of operatorship?
Okay, thank you very much for all questions, especially for the participant and the panelists. Let me see the future of the deepwater potential in Indonesia. Based on the literature and the presentation, we know many basins in Indonesia, especially in the western, undrilled. So, and we know about the potentials resources in Indonesia of oil and gas in eastern is more until about 70% of the total the potential of resources of oil and gas in Indonesia. So I think in the future, deepwater is very good for to get the explorations to get a target of the production of Indonesia, 1 billion barrels of oil. And I think my friends, let's to our group to continue the answer.
Thank you, Mas Rahmat. I guess it's a good point, yeah. But again, to answer that question, we just need to go back to the data we have, right? Number of basins that we have that has been not explored, where the water depth with environment water depth is there, right? So if you're talking about numbers, you can see it on the east part, or even in the western part of Indonesia, right? Here again, we're not talking about the resource in particular in our paper, right? But again, talking about the water, we're talking about the easiest of to drill the wells in terms of the location, you know, because it's remote location. So normally, once one of the resources being unlocked, and then start all the small pieces around it, you can start tying. So I guess it's a good feature for us to able to boost the production and then support the government's plan or program for 1 million barrels per day and also the 12 BCF per day for the gas.
Okay, thank you, Pak Roni. Hope that answered Pak Rahmat Sinaga question. We have another question from Pak Tommy Sugiarto. So it was a great and comprehensive presentation, Pak Roni, he said. So what do you think future of deepwater well in Indonesia, considering the high cost and uncertainty of stakes? So how many % can deepwater well contribute to the Indonesia production in the next 10, 20 years from now?
Okay, I'm sorry guys, I just need to take this one ya, Mas Firman and Mas William. Yeah, Pak Tommy, thank you for the question. Again, I know this is Deepwater, and then we're talking about the major project, right? Well, again, it's always UUD ya, ujung-ujung duit. So even though if it's talking about the or dealing with a lot of money, if the resource itself is big. So I went to one of the presentations lately today's with impacts with a giant abadi with the huge structures like almost twice of Jakarta city. Can you imagine that? Yes, we're talking about mega project cost, but again, we're also talking about the NPV and also the returns that might be gain for the operator and also the government again. So there is always it's a new features, I guess, for the voter. But again, maybe we need to take a look in our PAC scheme and so on, just to give attraction, yeah, for the operators around the world to come and then start to digging an oil or gas in Indonesia. Thank you.
Okay. Hope that answered Pak Tommy Sugiarto question. And there's a question from Pak Daniel Sitorus. Any Capstack membership information?
Yeah, I'm sorry, Mas.
Yeah, any Capstack membership information?
Yeah, well, it's a good point. Yeah, about the capping stack, I guess.
Yeah,
I believe
capping stack.
The question. Yeah, and this is we're talking about Deepwater, right? So as you know that what's happening with the Macondo, right? So before we drill the wells, for sure, all of the operators that will operate the Deepwater operation might need to have a kind of to secure possibility to grab on the capping stack equipment. Yeah, a lot of providers, right? One of them in Singapore, one of them in Houston, but just to make sure that all of those equipment able to be in place when the time is needed, when the incident is happening. So I guess all of the operators know that when we deal with the Deepwater.
Okay. Yeah, there's a following question from that question, Pak Ronnie. So yeah, what Pak Daniel want to know, is there any newcomers in the business on that Capstack?
Again, there are a lot of version of the equipment again. I'm sorry, it's out of the context of the paper, but again,
yes.
there is also coming with new equipment with more light in terms of weight and easily to be brought up to the country and then put in pieces so easily if something happened. But again, the players, it seems like still the same that we have in the worldwide. Yeah.
Okay. All right. So another question from Pak Kostam. Any idea on the rig cost per day for plotter rig over the years?
Yeah. Thank you, Pak Kostam Siregar, for the question. Just depend on the oil price. Yeah. When we're talking about the rate or spread costs, everything is depend on the supply and demand. So as you know, when oil price going high and then the demand on the rig and also services is also becoming high. So it's, you know, a lot of competition, and then the rate paid per days or the spread cost is becoming higher. But again, we're talking about like 800K to 1.2 million back on 2014, I guess, per day.
Yeah, I think we can. I mean, it can easily done by the market research. All right. Last question from Pa Hendra. He said, "Great effort for this study. Do you also have the subsurface data from all deep water wells?" And he asks, "Please advise minimum reserve that it will make drilling one deep water economic."
Anyone want to answer the question, Mas William? Okay. Anyway, well, there is a limitation on this paper. We're talking about the data, right? but just to have you an idea about one of the operators in North Sumatra Basin, the security POD with a certain 200-ish BCF, but still not being developed yet. But I don't know what is the reason, but based on the POD is being approved means that it's going to be some profit on it. But yes, that's the condition, I guess, is depend on the priority for each operator, right? When they are about agree with the FID, final investment decision, they need to be compete with the others with their other block outside the country.
Okay. I think last question is from Bumeta. Very interesting presentation. Yet eye opener. We need more luck to find hydrocarbon in offshore Indonesia, and luck to put it on stream as well. Based on your studies, what is the % success of deepwater exploration in Indonesia compared to other region? You're on mute. Sorry.
I'm sorry. Yeah, thank you, Ibu Meta Silaban, for the question. Well, talking about the technology, specifically for the seismic, I know when we build the Wildcat, we are like buying a cat inside there. Don't know it inside, right? But a lot of good technology, specifically about the subsurface, like the seismic that we have now, showing a good bright and some certain of structures that is giving us good success ratio before we start drill and do a decision for drilling. Well, again, in relation with this paper, we're showing that a lot of basin in Indonesia, from 128 basin that have been explored, all of them. So means that there is still a lot of opportunity there. But again, if you're talking about exploration, there's always dry and there is possibilities of success. So hopefully that's one of the work that need to be done by all of Indonesian people, right? Just to support the program of the government.
Okay, great paper by Ronnie and teams. Unfortunately, we have very limited time, and we have come to an end for this session for today. I hope your studies will help and can be used for other studies or any related requirement for information. And I think Pak Ibak can close this session.
Okay, thank you, Pasang, for the good presentation and discussion today. Thank you for the presenter and the co-author, and mainly the audience to attend to this session. If you are interested more about this paper, you can download at the IPA website. Of course, this is limited for the IPA member only. Don't forget, we still have more session coming tomorrow and the day after tomorrow. You can check or download the detailed schedule on the IPA Convex website at the convex.ipa.org.id. At last, thank you for the sponsors who contribute to this event.
Platinum sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, Uharbor Energy Company. Bronze sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo.